Hi, fourth graders. We're looking at lesson 7 in unit 8. I'm on page 319 of my book. And today we're looking at parallel lines. This is review from third grade. You've seen these before. Notice that in our book we see the difference between line and line segments. So you've got some lines that are parallel. Remember that lines go on and on in both directions with arrows, and then line segments end. There's an end point on both sides. But you can still have parallel lines and parallel line segments. Notice that these over here are not parallel. So try to think back to third grade. What does parallel mean? If you're thinking about the fact that these lines don't touch each other, even if you would trace them and keep going further and further, these line segments would not touch. Same with these line segments, and these lines. But over here, we can see that eventually these two would touch each other. If you kept tracing it down and you kept tracing that one down, eventually they would intersect. We call that intersecting. And so even though they're not touching, they're still not parallel because they would touch at a certain point. So in order for two lines to be parallel, it means that if you kept going with them, they would never touch. So in your assignment on math expressions today, you're going to have to draw parallel lines. You can do them vertically or horizontally, either way. Notice that it asks me to draw lines, not line segments. So I remember that lines have arrows and points. I can even label this is line AB and this is line CD. Here, draw and label a figure with one pair of parallel line segments. So here I'm supposed to make a shape with one pair of parallel line segments. We haven't really done this much yet, but we can do it. Think about this. If I made two lines that were parallel to each other, but maybe this one's longer than the other one, and then I connect them, these two are parallel. These two here, they run parallel to each other. But does this one and this one? No. If they kept going, eventually they would touch. So this figure only has one pair of parallel line segments, and then of course I have to remember to make them segments. So I have to make sure that I put in my points and that they end. I don't have the arrows going on past them. Okay, on the next page I noticed that it has defining perpendicular lines. So remembering from third grade that perpendicular means that they do touch, but it's a little bit pickier than that. They have to come together at a right angle, at a 90-degree angle. So remembering our code for that we learned a couple lessons ago, we put in that square, and that shows that it's a 90-degree angle. Notice that you can have two line segments that come together as perpendicular lines, and nothing is going past this point. That's fine. Or you can have two lines that cross in the middle and then keep going out from either side. All of these are showing perpendicular lines. But over here, you'll notice that they're not perpendicular. And now you might be thinking, but wait, those touch. I see them, they intersect right there. Those come together. These do too, actually. But notice that when they come together, the angle that they create is not a right angle. That makes it not perpendicular. All of these angles are not squares. They're not a 90-degree angle. So when you look at question 4, what do you think it means for two lines to be perpendicular? There are two lines that intersect at a 90-degree angle, at a right angle. Okay, down here you're drawing perpendicular lines. So again, really paying attention to the directions. If it says perpendicular lines, I have to make sure that I actually make my arrows. This kind of thing gets kind of picky in fourth grade. And the reason it gets picky is because we really need to make sure that we show that we know the difference between a line and a line segment. So in order to show that I know that, I'm putting in arrows to make sure that, of course, yes, I have lines and not line segments there. And then to be even more clear, I draw my square in there to show that it's a right angle. Number 6 asks me to draw and label a figure with one pair of perpendicular line segments. So again, I have one line segment there, and then another line segment here, and they are perpendicular. It just says a figure, so I think that I can connect these two like this. Now I've got a triangle, and it only has one pair of perpendicular line segments. This is not a perpendicular angle, neither is this, not a right angle. So that answers that question. On to page 321, we're identifying types of lines here. So you're telling whether each pair of lines is parallel, perpendicular, or neither. So check it out. What do you guys think this one is? If you said perpendicular, you would be correct. You're probably going to have to type this word into your math expressions lesson, so making sure you're paying attention to the spelling. What about over here? Are these parallel? Are they perpendicular, or are they neither? So they're not parallel, because if they would keep going, they would eventually touch each other. So we can't say that they're parallel. Can we say that they're perpendicular? No, because when they intersect, they don't intersect at a 90-degree angle. So the answer to this one is neither. All right, and then here we've got two parallel lines, so that one is pretty easy because we see that parallel means that they keep going on and on in both directions without touching. Something I like to remember when I'm figuring out how to spell the word parallel is this double L in here. I always used to forget that until I realized, wait a minute, those two L's beside each other make a little mini set of parallel lines. So that's how I started to remember it. But then I accidentally started making an L there too, and I realized that I only have one set of parallel lines in the word parallel. What about number 10? What are we thinking? They don't look perpendicular because there's not a right angle. They're not parallel. They do touch each other, but since they don't touch each other at a right angle, they're not perpendicular, so they are neither. It's important to be able to identify neither on this one, I think, because they like to throw a lot of those tricky ones at you. Numbers 11 and 12 just have you drawing different line segments. If you have time and you want to, you can. Without a ruler, I wouldn't be too picky about the measurements. Just do the best that you can. All right, and the last page of this lesson is lines on a map. So we've seen a map like this before where we've got a town and different characters are traveling to different places. Number 13 says, on Wednesday, Dell leaves his house and walks west along Lincoln Street. Gigi leaves her house and walks east along Jefferson Street. What kind of lines are Lincoln Street and Jefferson Street? Okay, so I find Lincoln, maybe I trace over it. I find Jefferson. What kind of lines do we have there? If you said parallel, you would be correct because they go on and they would never touch. Will Dell and Gigi ever meet if they're traveling on those streets? Nope. They won't, because if he is walking on Lincoln and she is walking on Jefferson, those streets just keep going straight. They're never going to meet, so they will just keep wandering without each other. On Friday, Dell leaves his house and walks south along 5th Street. I'm reading problem 15. So he leaves his house. Here's his house. He walks south along 5th Street. Gigi leaves her house and walks east along Jefferson Street. Okay. Well, Dell's on a different street now, you guys, so I think that they are going to meet at some point. What kind of lines do those form? If you said perpendicular, you would be correct because we've got that 90-degree angle there in the corner. And then the next question asks, will Dell and Gigi ever meet, and if so, where? So now we can see, oh yeah, obviously they would meet because the streets are going to intersect. And then whenever you're talking about street directions, you have to say on the corner of or at the intersection of. So looking here, I can't just say they would meet on 5th Street because 5th Street could be way up here. This is going to be important in your math expressions lesson. So you have to think, well, what two streets are meeting? The correct answer here would be they meet at the intersection of 5th and Jefferson. Or you could say they meet where the street where 5th Street and Jefferson Street come together. That's the spot where they will meet. All right, have fun with your lesson. I will talk to you later. Bye-bye.